we have a system of equations, and our task is to solve them in each of 4 different ways. Okay. What are the 4 ways in which we can solve a system of equations? We can solve by elimination. We can solve as a matrix equation using the inverse. We can solve as an augmented matrix using row reduction, or we can solve by graphing. Okay, so if we solve by graphing, let's just start out with graphing. Of course, we have to know how to graph a linear equation, and we've done that, and I'm not going to go through the details of that and give a detailed explanation. We've done that, and people probably need to review this, because I have noticed people aren't all that adept at graphing linear equations. It was an early topic, review it. Just take the first equation, 4x minus 3y equals -2. How do we graph that? Well, the easiest way is to find the intercepts. Now, there are other ways, but in this case especially, the intercepts are pretty easy to find, and they're pretty far away, which makes it easy to get a good graph using the intercepts. So, the x-intercept, that's the point where the graph crosses the x-axis. That occurs when y is 0, because, of course, on the x-axis, the y-coordinate is 0. So you set y equal to 0, you get 4x equals -2. You divide both sides by 4, you get x equals -1/2. So the x-intercept, and I just said these were kind of spread far apart. Actually, that's not the case here, it's just the opposite. Anyhow, the x-intercept is -1/2, so that would be like here on the x-axis. The y-intercept, you let x equal 0 and solve for y, and you get very easily y equals 2/3. So you would be on the y-axis, where x equals 0, of course, at y equals 2/3. 2/3 of the way between 0 and 1 would give you a line that looks something like this. I made a comment earlier, these points are spread out, and of course that's what you get for this graph. Since these points are close together, it's very easy to miss the slope if you don't plot those points exactly right. So we're not going to expect this graph to be of high accuracy. Okay? We're not going to expect miracles on our estimate for the solution to the system. However, there's a reasonable approximation of the graph. Now, the 5x plus 7y equals 19, we do the same thing. To find the x-intercept, we let y equal 0, because, of course, the x-axis is where y equals 0. We get 5x equals 19, so x is 19/5. Where's 19/5? Well, what's a multiple of 5 that's close to 19? 20. 4 times 5 is 20. If this was 20/5, we'd be on the x equals 4 point of the x-axis. We're a little bit short of that, so I've indicated that. I'm not sure my graph really looks like it probably went closer to the x equals 4 mark than to the x, but we understand what we would do if we try to graph that accurately. To get the y-intercept, of course, the y-axis occurs when x is 0. We let x equal 0, we get 7y equals 19. Y-intercept is 19/7. And we plot that, and of course, that's a little bit short of 21/7, which is 3. And it's more than 14/7, which is 2. Closer to 21/7 than to 14/7, so it's closer to 3 than it is 2. So if here's y equals 2 and here's y equals 3, we're going to be somewhat closer to y equals 3 than we are to y equals 2. So that's where I kind of slopped the thing down. And we draw a line through these points. And then we find the point of intersection. That's the point where, at least according to the estimate of the graph, that's the coordinates of the one point that would lie on 2 lines, meaning that those are the numbers that would satisfy both equations. Well, it turns out we didn't do all that well. Somebody wanted to say, well, that looks like about 1, 2. And I said, well, yeah, it's a little to the right of 1, a little above 2. So let's make an honest estimate here. And somebody estimated 1.3 here and 2.4 here. Now, you might agree with those estimates. You might think that one of them or both of them might be a little bit off. You can make your own estimates. They're not unreasonable. Okay, so 1.3, 2.4. This would mean x equals 1.3, y equals 2.4. So the solution we get from the graph estimate estimated solution is x equals 1.3, y equals 2.4. Okay? Now, we proceed to another method. And I just let people choose which method they wanted to use. I dictated graphing because when we went through the whole class, nobody thought of graphing. There were people who started doing elimination. There are people who wanted to write down the matrix equation, people who wanted to write down the augmented matrix first. But nobody thought of graphing. Graphing gives you the picture. It's very important. But if you want an accurate solution, you're going to use one of these three methods. Graphing gives you a reasonable approximation, but it also gives you a picture of the two lines. And we know from previously, if the two lines aren't parallel, they're going to cross in a single point. If they are parallel, maybe they cross, or maybe they coincide, and maybe they're completely separate. If they coincide, there are infinitely many solutions. If they're separate, there are no solutions. Okay, so you get one solution if the lines don't have the same slope, either no solutions or an infinite number of solutions if they have the same slope. Okay, well, anyhow, elimination. Now, to do elimination, we try to match up coefficients of either x or y so that we can eliminate them. Now, the way we match them up is, the best way to do that, I think, the way I recommend at least, is to make the coefficients equal and opposite so that we can add the equations and make that particular variable go away. We really want to try to avoid subtracting equations because we get into negatives of negatives and that can get confusing. It's error prone, not that we can't do it, not that we don't know how to do it, but it's error prone. So what I do here is I choose to match up the x's. Now, at least one person in the class chose to match up the y's because they have opposite signs. So there's good reason to do that. But I went ahead and decided to match up the x's. So here's our system. Now, to give the x terms, I'm just looking for the word term, I want to say variable. Okay, anyhow, to get the x terms to have equal and opposite signs, equal and opposite coefficients, well, if we wanted coefficients to be equal, we could multiply this equation by 5 and this one by 4. If we want to be equal and opposite, we're going to multiply one of them. Well, one of those numbers will be negative, okay? So I chose to multiply this equation by 5, which is going to give me 20x, right? And then this equation by negative 4, which will give me negative 20x. Now, when I multiply the equation, I multiply every term in the equation, distributive law, and multiply both sides by the same thing. And I have 5 times 4x minus 5 times 3y equals 5 times negative 2. And then I multiply this one by negative 4, so I have negative 4 times the 5x, negative 4 times the 7y, and negative 4 times the 19. And I just write the equation down that way. Then I do the multiplication. And of course, I don't have to read that to you. I get 20x. From here I get negative 15y. From here I get negative 10. From here I get negative 20x, which is a good thing because I wanted these coefficients to be equal and opposite. And then I get negative 28y and negative 76. Adding these, 20x and negative 20x gives me 0. Negative 15y and negative 28y gives me negative 43y. Negative 10 and negative 76 gives me negative 86. So I get negative 43y equals negative 86. Now, we shouldn't reach for a calculator. These are 2-digit numbers. It's pretty easy to see if we think about it that this is about twice as big as this one, and if we check it out, we see that it is in fact twice as big. Okay? If we divide negative 86 by negative 43, we get 2 because 86 is twice 43. So our solution is y equals 2. That's a solution for y. Now we could compare that with our estimate, which was 2.4. Our estimate was somewhat high. My picture was somewhat inaccurate. And it was a result of my picture that caused the estimate to be somewhat off. And I'll say now the person who thought that y was 2, wanted to say y equals 2 immediately, was right. Very good. Okay, well, we've got y. How do we get x? Well, if y is 2, and if we substitute y into either of these equations, we'll get the x-coordinate of that particular line when y is 2. Since the lines cross at this point, we'll have the x-coordinate also of the other line when y equals 2. Well, okay, we substitute y equals 2 into this equation. So it's going to go into y. So we're going to have 4x, still there, minus 3 times y, which is negative 2, and that equals negative 2. We solve that equation. I don't have to solve that equation for you. I mean, I'll read it to you. You get 6 here. Something's wrong. Oh yeah, okay, never mind. No. Okay, y isn't negative 2, y is 2. So the thing was wrong was I wrote an extra negative. So you remember what I was telling you about negative signs. It's really easy to get confused, and in my case it's apparently really easy to write down a negative. I have that in the corner of my eye. That's my excuse, but it's no excuse. Okay, so it's 4x minus 3 times 2 equals negative 2. That's 4x minus 6. If I add 6 to both sides, I get 4x equals 4. Divide by 4, I get x equals 1. So my solution is 1, 2, which is what somebody wanted to tell me earlier. Okay, well, there's a solution. So the solution, x equals 1, y equals 2. Okay, well, we'll go on in a minute. We'll do the augmented matrix and very likely the matrix equation.